In this section, we will discuss the Motion View on Board (MVOB) programming software and the basic position servo drive configuration. Position servo drives feature Motion View on Board (MVOB) software. The MVOB software is a Java-based software package embedded within the drive. The user simply uploads the programming software out of the drive onto their PC using a standard web browser. With MVOB, there is never any concern of either a service technician or a customer ever being without access to the programming software for the drive or having the correct version of software to be compatible with an installed drive. The software they need is ready to access at any time from the drive itself. To access the MVOB software from the drive, connect the PC's Ethernet port to the drive's Ethernet port. Set the PC's IP address to be on the same subnet as the drive's IP address, and then simply type the drive's IP address into the destination field in your standard web browser. That's it! We will go over this process in detail over the next few slides. Use an Ethernet crossover cable to connect the PC's Ethernet port directly to the position servo. If a hub or a switch is used, a patch cable should be used to connect the drive to the switch. We will need to set the PC's IP address to be on the same subnet as the position servo drive. Most corporate and home networks assign the IP address to the PC automatically. In this case, however, we want to manually set that IP address. When we set the PC's IP address, it will no longer be able to communicate to your local network. The IP address, however, is unique for the Ethernet adapter, so if your PC has more than one Ethernet adapter, each has its own configured IP address. If you use a wireless connection as your main network connection, there will be no issue. If you use a hardwired connection, you may find it easier to purchase a third-party USB to Ethernet adapter for your PC so that you do not have to disrupt your connection to your corporate network. USB to Ethernet adapters are readily available and quite inexpensive. They certainly are not necessary, however, they are very convenient, allowing for you not to have to adjust your settings when you want to program a drive. To access your TCP/IP settings in Windows XP, you first need to enter your control panel, then double-click Network Connections. Double-click on the local area connection that you'll have the drive connected to. Here's a quick tip. If you disconnect the cable from the PC that you will be using, you'll be able to see the correct icon change, adding a red X over it. Reconnecting the cable will make the icon change again. The red X will disappear. Now click on the Properties button. Scroll through the list and first left-click on Internet Protocol. Then left-click on the Properties button to access the IP address window. Select Use the following IP address. Then enter the address that you want the PC to assume. The default IP address of the position servo is 192.168.124.120. You will want to set the PC to 192.168.124.xxx. XXX can be any number between 1 and 254 that is not already used by another device on the network. The default value of position servo's last octet of its IP address is 120, so any address other than 120 will work if the only two devices on the network are the PC and the drive. For example, you could set it to 1. Enter 255.255.255.0 for the subnet mask, and then click OK. To load the MVOB software from the drive onto your PC, you will now need to launch your web browser. Type the drive's IP address into the web browser. Again, that default IP address is 192.168.124.120. If you are unsure of your drive's IP address, you can check it using the front panel display on the drive, as we discussed in the last section. After you type the IP address into the destination address of the web browser and hit Enter, the MVOB software will load onto the PC. Depending on your security settings, you may be prompted to allow download of the file, and you may also then get a pop-up asking you to confirm you want the software to run. Allow the software to open and allow the software to run in order to start MVOB. Once MVOB launches, you will be ready to start configuring your drive. After launching Motion View for the first time, a Motion View Java icon will be placed on your desktop. The process of setting the PC's IP address under Windows 7 is a bit different from using Windows XP. Again, start by going to the Control panel, then double-click on Network and Internet. Next, you will need to double-click on Network and Sharing Center. From this point, you need to click on Change Adapter Settings. Right-click on the local area connection that you are using to connect to the drive. Quick tip: just like in Windows XP, if you disconnect the cable from the PC that you will be using, you'll be able to see the correct icon change, adding a red X over it. Reconnecting the cable will make this icon change again. The red X will disappear. Now choose Internet Protocol version 4 and click Properties. This step is identical to using Windows XP. Select Use the following IP address, then enter the address you want the PC to assume. The default IP address of the position servo is 192.168.124.120. You will want to set the PC to 192.168.124.xxx. XXX can be any number between 1 and 254 already not used by another device on the network. The default value of the position servo's last octet of its IP address is 120, so any address other than 120 will work if the only two devices on the network are the PC and the drive. For example, you could set it to 1. Enter 255.255.255.0 for the subnet mask, and then click OK. Type the IP address of the drive into the destination address of your web browser, open the MVOB software file, and then allow it to run. With Position Servo MVOB, the user always has the software they need for the drive whenever they need it without question. Once MVOB is launched, you will want to connect to your drive. To do so, click on the Connect button on the left-hand side of your toolbar. Clicking the Discover button will cause the list of IP addresses of available Position Servo drives to be populated under Connect to Drive. You can click on the IP address of the drive you want to connect to, and then click on the Connect button. A quick note: if your PC has more than one Ethernet adapter, the Discover button may not be able to detect any drives. You can still connect to your Position Servo drive in this case by simply typing in the IP address of the drive in question manually in the IP address field and then clicking on the Connect button. The Save Connection button saves the communication path to the drive you are currently programming, but not the drive's program itself. This is useful during development of multi-axis systems. The Load Connection button loads a saved connection path. Once you've connected to a drive, you are ready to configure and program. Click on the Drive folder. The Drive folder is set up as basic tree navigation for ease of use. The MVOB programming screen is broken into 3 basic windows. The parameter tree window is used to navigate through the drive's navigation tree. The parameter view window is used to access the individual parameters for the drive features contained in the navigation tree selection. The message window gives individual program status indicators, such as connected to drive, disconnected from drive, progress of loading, or programming errors. For example, if you select the motor file in the navigation tree, you will be able to access the motor parameters. We will now begin exploring the navigation tree and discuss the configuration features of the drive. Click on the Drive node, the drive's top line in the navigation tree. This will show the drive's basic information, including its firmware and hardware revisions. This screen also allows you to assign a name or alias to the drive. In this example, the drive is named X-axis. You can also set the group ID number for the drive. This is an advanced field used only in drive-to-drive messaging using the send to logic command. For further information on the send to logic command, please refer to the Position Servo Programming Manual. Next, let's explore the motor selection of the navigation tree. To change the currently selected motor, click the Change Motor button. The motor database contains over 600 motors from a wide array of vendors. Simply select the manufacturer and then the motor model number of the motor you will be using. Once you have selected your motor, click the Update Drive button to load the motor selection and motor data to the drive. If the motor is not in the database, the user can create a custom motor file. Simply select Custom Motor and then fill in the prompted motor information. Once entered, the user can save the custom motor file and then select Update Drive to save the motor parameter settings to the drive. Please configure your motor now. After configuring the motor, the drive needs to be tuned. The Position Servo incorporates an advanced auto-tuning feature to make setup of the system both quick and easy. We will walk through this process in this follow-along lab. The tuning parameters and functions are located on the compensation selection of the drive's navigation tree. With the indexer code stopped, select Compensation from the navigation tree. Then, deselect Disable High Performance Mode. Disable High Performance Mode is selected by default to facilitate users replacing a first hardware generation Position Servo drive with the current product offering. Next, turn on Input A3 and click the Auto Tuning button. To tune both the position and the velocity loops, select both the Position Tuning and Velocity Tuning checkboxes. When it is safe to move the motor, click the Start button. Finally, once auto tuning is complete, select Yes to save the gain settings. For advanced applications, the drive incorporates a feedback filter with a programmable time constant to counteract noise from the motor feedback signal. It also incorporates two advanced loop filters which can be configured. A generic low-pass filter may be selected, a resonator filter may be selected to counteract mechanical resonance, and a notch filter is also available. A notch filter is useful in dealing with a non-uniform mass distribution on the load, eccentric loading, and also on tuning vertical applications. Auto-tuning must be rerun after enabling filters for proper response. The parameter screen accesses the drive's basic configuration parameters. The next few slides will discuss the commonly used parameters and their settings. Fundamentally, the drive has three modes of operation: torque, velocity, and position. Use the drive mode setting to select the mode of operation for the application. Note, the drive mode can be altered logically by the user program whenever the drive is disabled. This field sets the mode first used when the drive boots. Reference refers to the source of the drive mode's command. In other words, what does the drive look at to determine what it should be doing from the drive mode being used? In the case of torque mode, this indicates where the output current level command initiates from. In velocity mode, reference identifies the source of the velocity command. For position mode, it identifies where the reference for relative position originates from. The drive can have two possible references, either internal or external. Internal reference is taken from the drive's internal variables. External reference is analog input 1 for torque or velocity modes. External reference for position mode is either a master encoder or a step and direction signal. The servo loop solves in 62.5 microseconds. Torque regulation is specified for a 100-to-1 range with a 1% accuracy of maximum current rating for the drive model. Servo torque control regulates current to the motor to control the motor's torque. Motor torque is proportional to the kT, torque constant, of the motor in question. A torque command can be from an analog signal from a device such as a motion controller, or can be logically manipulated by the drive's user program. In torque mode, the motor will produce the commanded amount of torque. If load is not present, the motor speed will run away. Examples of torque control applications include nut runners, web tensioners, and labelers. Motion controllers will often use the drive in torque mode, giving the drive an analog torque command and referencing the drive's buffered encoder output to solve the position loop. This slide shows the action of a typical nut runner. The axis turns at a given amount of torque to ensure the bottle is sealed properly. The velocity loop update rate of the position servo is 512 microseconds. Speed regulation is plus or minus 1 RPM over a 5,000 to 1 velocity range. Analog control is, however, limited to 11 bits plus sign, so 2048 divisions are possible from a 0 to 10 volt DC command signal. Velocity mode regulates the speed of the motor. However, the drive will not allow its peak current limit to be exceeded. Analog input 1 can be used as a velocity command, or the drive's internal variable, IREF, can also be used for this purpose. While in velocity mode, there is no position error checking. As such, if the torque required to rotate the motor at the commanded speed is in excess of the torque limit, peak current limit setting of the drive, the axis will lose velocity without fault or error. This can be useful in certain torque applications where the possibility of a runaway could exist. Application example AE8 in the technical library of the Lenze America's website covers this concept in detail. Basic examples of velocity control applications include conveyors and wafer spinners. Some motion controllers will give the drive an analog signal for the speed reference and use the buffered encoder output to solve their position loop. This is an example of a wafer spinner. The position loop update rate is every 512 microseconds. When used with an external reference master encoder signal, the drive can follow position signal frequencies up to 2 MHz. During execution of motion, deterministic program events can be run by the user logic program. This provides application flexibility. During position mode, velocity and torque are monitored so as to provide correction to the axis, keeping it in the proper position at the proper time. If the torque required to move the axis exceeds a torque setting, peak current limit setting, the drive will be unable to keep the axis in proper position and will fault with a position error once the error exceeds the user-programmed limits for both time and magnitude. This graph shows the correction a drive will attempt due to a torque disturbance. If the torque required is below the torque limit, the correction will be possible. Examples of position control applications include case packers, indexing tables, pick-and-place machines, and flying shears. Here you can see typical action of a case packer traversing back and forth from programmed positions. The position servo can be programmed to use either 8 kHz or 16 kHz carrier frequencies. 16 kHz provides quieter operation at the expense of being less efficient. This loss of efficiency results in the peak current rating of the drive being derated by 17% when the drive is used at 16 kHz carrier. Both 8 and 16 kHz are out of the audible range for human beings. The drive uses space vector modulation for greater DC bus utilization. The external reference type for position mode is set by the master encoder input type parameter. Either a step and direction or a master encoder can be configured. In either case, the drive can also be set for an electronic gearing ratio off of that external reference. The ratio is expressed as 2 integers, counts of the master, set under master, to desired resulting counts from the position servo system, set under system. Again, as these are in counts, both fields are entered as integer values. The user units field is used to internally scale motor revolutions into actual user units. For example, if half a motor revolution resulted in 1 inch of displacement of your axis, and you want to work in inches, set the user units to 0.5. If 2 revolutions of the motor resulted in 1 inch of displacement, and again you want to work in inches, set user units equal to 2. Under the Communication main heading in the navigation tree, there are 4 pages that can have parameter settings: Ethernet, RS-485, CAN, and Profibus. Selecting the Ethernet tab will allow you to view and change the drive's IP address. The Digital I/O selection in the navigation tree provides access to the programmable aspects of the drive's digital I/O. The drive's outputs can be configured to turn on and off for given conditions, such as when the drive is at 0 speed, to control the brake function, or when the drive is at current limit. If you want the drive to manipulate the I/O by using the user logic, set the output to Not Assigned. You can program a debounce time for each digital input to minimize the effects of noise. Inputs A1 and A2 can be set for normally open limit switch functionality. To do this, set the hard limit switch function to stop and fault. Input A3 must always be activated for the drive to be enabled. If you will be using an external reference to command the drive without user logic, set the enable switch function to run. This causes input A3 to enable or disable the drive directly. If you want user logic to command the drive to enable or disable, set the enable switch function to inhibit. Input A3 will still need to be asserted in order for the drive to enable. However, simply asserting input A3 will not command the actual enable function. It prevents the enable function from executing if input A3 is not asserted. Select Analog I/O from the navigation tree to access the configuration parameters for the drive's analog I/O. The analog output can be configured to indicate several possible data selections. These include phase current and motor velocity. If the analog output will be used to indicate drive output current, you will need to program the analog output current scale. If the analog output will be programmed to indicate the motor velocity, you will need to program the analog output velocity scale. If you would like to command the analog output logically, set the analog output parameter to not assigned. If the drive is in torque mode with an external reference, the analog input current scale defines the conversion between the plus and minus 10 volt DC analog input signal to the drive's output amperage command. If the drive is in velocity mode with an external reference, the analog input velocity scale parameter defines the scale of the analog input signal to the motor RPMs. The velocity limit parameters are used to define conditions. Zero speed defines a bandwidth around 0 RPMs as zero speed. The speed window defines a bandwidth around the at speed value to define the condition in speed window. The position limit parameters are only used while the drive is in positioning mode. Position error defines a maximum allowable position error for the application. Max error time defines a maximum allowable time for the drive to be outside of its maximum allowable position error limit for the application. If the drive's position error is larger than the setting of the position error parameter for more time than the value of the max error time parameter, the drive will fault with position error fault, FPE. The in-position limit defines a bandwidth around the target position at the completion of a move for the drive to determine it is in position. The tuning parameters and commands for the drive are accessed by clicking on the Compensation heading in the navigation tree. We used this section in the first follow-along lab. The indexer program selection accesses the user program of the drive. We will cover programming concepts and usage of the compiler control buttons later in this presentation. The drive features a built-in oscilloscope to monitor basic drive functions. The oscilloscope and the parameter and I/O view watch window are both located in the Tools section of the navigation tree. Parameter and I/O view window allows the user to monitor any user-readable variable during the drive's operation. By clicking the Add button, the user can select any accessible drive variable and then view it in the window. The status of the digital I/O is also shown here, with the I/O point showing green when on. The Position Servo also features a monitor window, accessible from the navigation tree. This monitor window displays the status of all commonly accessed drive variables and the drive status flags. The fault screen always displays the drive's most recent fault code. To view the last 16 fault codes, click the Load Fault History button. To clear the drive's fault history, click the Clear Fault History button. Executing the Clear Fault History command can cause an interruption in motion. It is recommended to stop the application prior to executing this command. The main toolbar in MVOB also has selections for a user to print a hard copy of their program, save or load a configuration file to the drive, this is the drive's actual program, and also features a Stop Reset button so that the user can stop the running drive indexer program from any screen. This button is useful during initial program development and debugging of applications.